So when last we left off, we had created the AI service called ThinkMind AI Demos. And that was a service that we were going to use for our future development work. In this video, what we're going to be doing is creating an application that's going to basically connect to this AI hub and use the AI services that we've created here to basically, once again, calculate the GOAT score. And we calculate the GOAT score by determining who is the best player to ever play the game of basketball using the criteria associated with points, rebounds, assists, whether they've been in an NBA Finals, whether they've won a championship, whether they were the Finals MVP, bunch of different things all put together that instead of us coding, if we were coding this, it would take a long time. But because we're able to use an AI platform, we can basically write out our requirements and let the AI go out and fetch data as needed and use that data to basically do whatever it wants to do. So in order to connect to this platform, we're going to need a couple of things. We're basically going to need the URL that's specified here. That's the AI endpoint that we're actually connecting to. We're also going to need the key, and the key is not going to be exposed in this video, but basically you can copy that and paste that into your code, wherever your code may be, or better yet, in the pattern that we're going to create here, have a manager style class that essentially has all your keys, and then you just leverage and use those keys in your application. So I'm actually going to, first of all, create or open up, I should say, the AI Studio, and I'm going to open it in a new pane, because another thing that we're actually going to need is we're also going to need the deployment name. Before we get to that, let's go ahead and let's just create a console application. We're just going to call it, name it after ThinkMind AI Demos, I believe is what it's called. So ThinkMind AI Demos, there we go. I'm going to put it into the demonstrations folder. We're leaving this blank boilerplate. This is going to be a basic REPL application. It's really not meant to be fancy. It's just meant to demonstrate how you actually connect to an AI platform. So let's go back to the keys and endpoints, and we're actually going to copy the endpoint, and let's change the namespace like that. And we're going to just create a variable and store that endpoint value. And typically you would store this inside of a configuration file somewhere. But for the purposes of the demo, we're going to store it here. Next, let's create a class that's going to hold our keys. Again, there's a lot of ways you can do this. You can have a config file. Because I'm presenting here and I don't want to expose the key, I'm basically using a static file. And in this static file, I'm going to actually store the key value. Okay. And we're going to copy that over and paste it here. Okay, now we're done with that. And then let's also get the deployment. And then here, we're going to go back to the AI Studio. And if you go down to deployments, like I showed in the last video, you just copy that deployment name and we can paste it there. And we're gonna just use the key manager, that key here, so that we have the actual keys. And let's comment to sort of make our code a little bit readable for people so they understand what things are. So now that we have that, the next thing we want to do is we want to create a space where we can actually copy or write out whatever the program that we want the AI to know, the actual knowledge that the AI is going to know, and the instructions that it's going to use to do whatever it needs to do. And for now, we're not going to put anything in there, but we're basically creating a markdown file. And in this markdown file, we're going to write all the things that last week we wrote into the little text box in the playground. And if you follow the last video, we did the same thing, and we had it actually embedded into our code. Really don't want to do that because it's not really necessary to compile that piece. It's just needed to load. You can think of it almost as a configuration, even though it really applies primarily to the AI. So what we're going to do in this video is we're going to use better programming practices, and instead of hard coding it into the code itself, we're actually going to read it from that the markdown file. And it's prompt.md. So we just navigate to that path. Perfect. So now what we want to do is we want to actually paste the NuGet packages that you're going to need. And I'm just copying them over and pasting them. But essentially, you need Azure.ai.OpenAI, Azure.ai.language.question answering, and I usually add Newtonsoft, although it's not needed. You notice that the OpenAI library is in beta. And part of the reason of doing this video is because there was a refresh to the APIs that I used when I created the previous AI video. So I just wanted to update it so that you guys would have the latest way the AI is. So be mindful of the fact that this is in beta, right? So there is a chance that the AI can change relatively drastically. As a matter of fact, I would say it was a medium-sized change that occurred to get to this point. So it's not as if you had written code before, however you had it, that code is not going to work properly now, and it's not going to be very obvious to you what the changes are. So I kind of had to go through a little bit of trial and error to understand the nuance of how programming was meant to be done on these APIs. So just be mindful of that. So I've also disabled Nullable to make it easier. I wouldn't recommend doing this in your own programs. I would recommend learning how to work with nulls, being very clear if you want a type to be nullable or not nullable. That's really the prescribed way of doing things. And let's add the namespaces because we're going to be using these types in here. So we'll add it above the namespace declaration. All right, we are golden here. So now let's remove our silly hello world and let's start slinging some actual code to connect to the AI environment. So first thing we want to do is we want to take that string and we want to make it the system message, right? So this is what's going to bootstrap the AI and give it knowledge of what it should do and how it should think. So whatever we type in there is what's going to be used. And we will just put some commentary on that. And now over here, we want to actually connect to the AI platform. So we're going to be creating an Azure OpenAI client. And this will take the endpoint to the URL we're connecting to. And it will also take the key that we created up here. Okay, Azure AI credentials, and we want the AI key Oh, I called it key. Gotta change that to say AI key, not key. There we go. Minimize it so we can see what's going on here. Next, we want to actually now create a chat client from that OpenAI client, and it's pretty straightforward. Just get chat client, and in this case, you pass in the deployment name into the chat client. So you're creating a chat client for that deployment. And now we're going to set up a conversation. So the way AI works, as I type through here, is that it basically it takes the context of your answers and your questions and feeds it back into the platform, and that's how it sort of maintains context of what's going on. So in this case, we're creating a list that's going to represent the conversational context, and we're going to be adding multiple kinds of chat messages. The first message is our system chat message, which just says, "This is what you know." But any subsequent messages we will basically add over time as we loop through and type things in. Now, what I'm doing here is I'm basically creating completion options. Before, pretty much in the previous version that I created, all basically that conversation context was inside of the chat completion object. They've basically moved it out now, and the chat completion essentially contains configuration information about tokens and some configuration information about tools. Tools are a technique to extending your AI that we'll talk about in our next video. But for now, let's just keep it relatively simple. So max tokens is how many it's going to return for max. You already know what temperature is, and our stop sequence is basically no more sequences. So now we're going to go through and create our REPL loop. While true, it's going to be set as true. So let me create some space here because I'm not really, there you go. Okay, so inside of here, we're first going to read the value from the user. So I'm just going to create a prompt here. Let's call it simple.ai. Here we go. And then, so that's that we write out, but we do a write. We're not going to do a write line. So that when we do a read, the cursor is going to be right next to that. It's going to look like a normal console. So now we're going to do a read line, which will read the remainder of the line, the information that's been put in. And we want read line here. And then we want to stop, right? So we're going to say that if what I've typed is end, then, then just end the program. We're basically done. Just break from the loop. So everything after here means I haven't typed end. And so we're basically going to do an evaluation of it. So this is the eval part. So the first thing we're going to do, as discussed, is that we are going to add to the conversational context that information that the user has passed in. So as you can see, the first thing that was passed into the conversational context is the AI knowledge, which is actually a system message. The next thing that's passed in is what the user, the person typing in, passes in. And that's just the next item on the list. They all share a common base type of chat message. So all these are different kinds of chat messages, and there's even more, right? There's chat messages, as discussed, associated with tools. But in this case, we're pretty much working with just the user, the system, and what the assistant returns. You'll see that in a second. So now that we have that, let's make a call to the OpenAI to ask it to complete the information based on what we've entered. So we're going to use the asynchronous call to complete the chat. Oops. Here we go. We're passing in the conversational context, and we're also passing in the completion options, which tells us things like how many tokens we want to return. And of course, tokens are very important because you pay for tokens. So you want to make sure that you're very efficient with how you return tokens from calls. Okay, Okay, just making sure we got everything. Yeah, let's change that to a task because we are doing an async. All right, so next line here, now that we have the AI response, we've basically made the AI call. From your perspective, this is pretty much, this is connected to the AI environment that we have in Azure AI Studio and in Azure. And we've actually taken input from the user. We've passed input into um, uh, that environment that we have up there, and we've gotten a response back, right? So let's now read that response that we've gotten back, right? We've evaluated everything. So now we're gonna read and print that all out. So we're first gonna get the OpenAI the responses, which is just value, which is just called completions. You can have one to many of them, and now from that completions, we're actually going to pull out the first completion and just provide the text for that. That's the response that came back from the AI. In general, you can have multiple completions and you can pick and choose which one makes the most sense to you. And then we're going to add that back into the conversational context as an assistant chat message. So we had a system chat message, we had a user chat message, and now we have an assistant chat message, which basically is indicating to the platform that this is the response that came back from me. All of this, just like with you as an individual or with anything, all the conversation that you have helps inform future responses, future meaning and context associated with when a word is said. And when we get into the actual running of this, you'll start to see that at play. So now we've read it, we've evaluated it, and now let's print something out to the screen. So we're just going to do console.write line, and we're just going to print out the assistant message. And then we also print something letting the user know that that particular response is done. So just print, star, star, end. Let's go. And then let's create another line here. Oh, she's done, yeah. Let's create another line here just to create a little bit of gap between one response and another. So this is pretty much it. This is your program. This is the framework for your program. There's and believe it or not, but based, as you can see from this demo and this sample right here, based on the contents of prompt.md, this program that we have here can behave drastically different and return drastically different things. Again, that's the power of AI. To a certain extent, you're outsourcing the computational and almost like the reasoning around the product you're trying to build to the AI platform. It all goes there, gets processed there, and you get the responses back from that. So our code is pretty much done, or the C# part of our code is pretty much done. So let's go ahead and let's now populate the markdown file that represents the knowledge that the AI is going to be using. So I'm just going to copy and paste that in there. But you can see that it's pretty straightforward. You're an AI assistant that helps people answer statistical questions about past and present NBA players, as well as helps determine who the NBA GOAT is. You do this solely using the rules specified in the rules section below. If any question is asked, respond by if any other question, I apologize, is asked, respond by telling the user the kinds of questions you can answer. And then we look at the rules. The rules are identify the name that the requested player correlates to an NBA name. We don't want to just take anybody. If it does not, notify the user of what you have the ability to do. So we're looping back and saying, hey, here's what I have the ability to do. If a question regarding a player's career points, steals, assists, rebounds, or blocks averages is requested, provide that information, because we do more than just doing the GOAT score. We also provide statistics. If a player's GOAT score is requested, then do the following. I have two the following, but do the following. Get the player's rankings in the top 20 all time in the categories of blocks, steals, assists, points, and rebounds. Get the total count of the number of MVP awards the player received during their career. If a player has not won at least one MVP award, they are disqualified. We get the count of the number of finals MVPs the player has won, the number of Defensive Player of Year awards they've won, and the number of NBA championships that the player has won. And then we calculate the player's interim score by adding all those together. And then for points, we multiply it by 10. For rebounds, 5. Blocks, steals, assists, also 5. And if the value is less than 0, we don't do anything. And then we also multiply the number of MVPs they have by 15, the number of finals MVPs by 20, the defensive player of the years by 5, and the count of number of championships by 10. For a given player, we're going to add all those results together. If a player has more championships than finals MVPs, then we're going to subtract 5 points for every championship that they have that they did not win the finals MVP award associated with it. And the final result is the player's GOAT score. Now, under context, this is the information that's going to tell the AI what it basically knows. You know the top 20 ranking of NBA players in these categories. You know the number of MVPs won by previous and current players, number of finals MVPs, number of championships. And the next section is the response format, where we're basically talking about how we're actually wanting the AI to return the data to us. We're basically saying when a player's GOAT score is requested, respond with 2 sections. One of them is going to have all the rankings so that the user can see their rankings. There's no shady business going on. And then inside of the ranking section for each question, respond with the name of the player, the category of the ranking. If the player has no ranking, say that they don't have any ranking. And in the score section for each category, we want to know the score of the player for that given category. So we've got this all set up. Let's go ahead and let's run this bad boy. So let's ask, what is Jordan's score? And you can see from the bottom, after going through everything, that his final GOAT score is 510. So let's try LeBron James now. And here we have the score for LeBron James. And as you can see here, it's 515. And this is likely because they're second in points, ninth in steals, fourth in assists. So they're pretty high in several critical categories. And he's also won 4 championships, in which all of them he had a finals MVP. So he's edging out Jordan a little bit. And so now what we're gonna do is we're gonna speak to it, like continuing the conversation. So we're not gonna ask it what is Kareem's GOAT score. We're just gonna say, hey, and Kareem's, right? Just ask it like you would ask a normal person. So in the case of Kareem, as you can see, the score is 550. This is because it's actually 570. It's 550 because he did not win enough finals MVPs, based on championships. So even though he was a very good player at that time, he likely was not the best player on the team. Somebody else won finals MVPs. So because of that, of his 6 championship, he was really only the best player, the main guy in 2 of them, at least according to whomever, awarded the other people finals MVPs and not him, right? So his score comes out to 550. So there's a little bit of a problem here, right? And it's not immediately evident when you look at people like Kobe Bryant and Michael Jordan, LeBron James, Hakeem Olajuwon, people who have won a lot of championships. The problem is that we don't account for what it takes to get to the finals. So if, for example, we looked at a person like Jerry West, right? So let's see, what is Jerry West's code score? We're going to get a very low score, right? Because I don't believe he won a championship. Oh, he won one championship, right? So he got 10. So altogether, he has a good score of 45, right? But the problem here is that Jerry West was actually had a lot of finals appearances, and getting to the finals is no small feat. It's a championship in and of itself to a certain extent. Maybe not at the extent of winning and being finals MVP, but it certainly does deserve some consideration, especially when you start mounting, right? So what we're gonna do is we're gonna demonstrate how we can modify the code base of the model itself, the prompt itself, without actually changing any code in the application at all. And what we're gonna do is we're gonna add some rules to it, right, to basically allow for finals appearances to be added to it. I'm going to go through a couple of steps to show you sort of how these things work and how the language of it might work. So first of all, I'm saying multiply the count of the number of finals appearances by 5. So we're just going to add that to it and see how that works. And when I run that, you're going to see that it's still showing as 45. Well, why is that? Why is it not showing the correct information? Well, let's take a look at that. So right now, what we have it saying is multiply the count of the number of finals appearances. So let's make it a little bit more specific and see if that helps, right? So NBA finals appearances by 5. And note, I'm also going to add the player has had by 5, right? So we're multiplying the count of the number of NBA finals appearances the player has had by 5. So when I run this and I ask the same question, I'm getting the answer of 120, but there is an issue here. And the issue is that I'm going to switch over to white so we can do it. I'm not seeing a reflection of the finals appearances here. So I'm not quite sure where this 120 is coming from. It doesn't seem to be coming from where we expect it to. So let's see if we can change that and fix the issue. So over here in this section where it says context, you'll note that, so far we just, what does the AI know? It knows the top 20 rankings. It knows the MVPs. It knows the finals MVPs. It knows the championships. So in here, let's tell it that it also knows for previous and current players how many NBA finals appearances they have had. All right. So now we have that and we save that. Now we run that. And let's try this again. We'll try with LeBron James as an example. And there you have it. So as you can see now, in terms of scores, we now have the 10 finals appearances times 5, which is 50. And we now have a GOAT score that's been updated to 515 plus 50, which would be 565. In this video, We extended our understanding of AI Studio by building an application that leverages the configurations we set up in the AI Studio and Azure AI within a console application. Tune in following videos where we'll take this even further by adding the ability to make tool calls and update your AI responses with up to the minute live data coming directly from external services. Till then, salute.